Dear students, welcome to the problem solving session on change of variable polar coordinates part 2. In the part 1 video, we saw some basics and we have solved a problem on circle. We understand that why this change of variable is needed. There are some situations where we cannot solve the double integration in a normal way. When the problem is getting tougher, we are adapting to change the problem into a different variable. One of the technique is changing the problem into polar coordinate and evaluating the problem in a simpler way. So we solved this problem in the previous video. Those who don't watch that video, please go to the playlist, watch that and come back to this video. In today's session, we are going to solve a different problem. This is also very interesting and tough problem. By change into polar coordinates, we have to prove this value as pi by 4 and hence we have to evaluate the value of integral 0 to infinity e power minus t square dt. Let us go into the problem, students. So since both the limits are infinity, I don't want to worry about to check the order. Step 1, as usual, I am taking the given integral as capital I. Step 2, we are going to transform the problem into polar coordinates. So I am writing x equal to r cos theta, y equal to r sin theta, and either dx dy or dy dx. It is going to be r into dr into d theta. From this two equations, we can get x square plus y square is equal to r square. So this is very common. You have to write this step and we have to write this as step 2. Now step 3 is equations. From the question, both x and y are varying from 0 to infinity. We can directly write in the table. Done. Step 4, now we are going to do the diagrams. So let us consider the axis. We know x equal to 0, that is my y-axis, and then we cannot draw infinity in a given region. So for infinity, instead of making a straight line, I am going to make a dotted line and I will tell this as a line x equal to infinity. Next we have the line y equal to 0. Similarly for y equal to infinity, I just make a dotted horizontal line and I will mention this as y equal to infinity. Now we can easily see the region. X moves from 0 to infinity, left to right, horizontal strip. Similarly, y moves from 0 to infinity in a vertical strip. Therefore, this is my required region. Now I have to convert this into a polar coordinate. The hold is here. We can see the hold at this point, that is my 0, 0. Now I can draw the strip anywhere because it is moving to infinity. Either I can draw like this or I can draw the strip to the y equal to infinity also. Both are correct because this case is the special case. Both are infinity. So I am drawing like this, which is common to both. So now our step 4 gets over. We have drawn the figure. Next, step 5, we have to write the limit, students. We know that the first quadrant is covered by the line y equal to 0 to x equal to 0. Therefore, my angle is going to be theta equal to 0 to theta equal to pi by 2. That is 90 degree. Next, r limit, the starting point is 0, 0. When you substitute in step 2, x square plus y square equal to r square. X is 0, y is 0. So r is also 0. And now it is moving toward infinity. In step 2, we have x equal to r cos theta, y equal to r sin theta, and then x square plus y square is equal to r square. Now when you put either x equal to infinity and y equal to infinity, r is also going to be infinity. Or you can substitute here also, you will get the corresponding r as infinity. R equal to 0 to r equal to infinity is my limits. Step 5 gets over. Step 6, we have to convert the Cartesian coordinate into polar coordinate. Let us write the question. So now outer limit is angle 0 to pi by 2 and the inner limit is going to be r, that is 0 to infinity, e power. We know x square plus y square is equal to r square from the step 2. So e power minus r square. Dx dy is r into dr into d theta. This is my conversion. So I change the variable into polar. Now we have to integrate this. But there is one problem. We know the integration formula e power ax dx is going to be e power ax by a plus c. But here we don't have e power ax. We have e power minus r square. So I cannot solve the problem using any formula. So in integration, whenever there is a problem comes, whenever you cannot proceed further, we always try to go for substitution method. Most of the time it works. So now minus r square is my problem. So I am going to assume this. I am going to assume t equal to r square. Dt is equal to 2r into dr. Dt by 2 is equal to r into dr. Now you can see r into dr is there. So I can easily convert this problem. Next, checking limits is very obvious because t equal to r square means when I put r 0, t is also 0. When I put r infinity, t is also infinity. So using this, I can solve the problem in a simpler way. Integral 0 to pi by 2, integral 0 to infinity, e power minus r square. So we know r square is t. So e power minus t, r into dr is dt by 2 into d theta. So that is what mentioned here. Now take this 2 outside. We know e power ax integration is e power ax by a. So e power minus t integration is e power minus t by minus 1. And we know the standard result e power infinity is infinity, e power minus infinity is 0. Now substituting the upper and lower limit, we get e power minus infinity minus e power 0. So e power minus infinity is 0. E power 0 is 1. We have this minus 1 outside. So minus into minus plus. So we get 1 by 2 integral 0 to pi by 2 d theta because this minus will get cancelled with this minus. So 1 by 2 integral d theta is theta. The limits are 0 to pi by 2. Therefore my answer is pi by 2 into 1 by 2, that is pi by 4. Therefore, the first part of the problem we proved integral 0 to infinity e power minus x square plus y square dx dy is pi by 4. Done. Next, we have to find this from the given result. Now, whenever we solve for exponential, I said never keep the function as it is. This is troubling me. Simplify this. You will be getting e power minus x square into e power minus y square. So substituting here, both the limits are constant. So I can rewrite this equation separately for x and y. Now you see what is the change between these two content. Only the variable is changing. Here we have x, here we have y. So I am going to take x equal to y equal to t. Therefore dx equal to dy is equal to dt. And limit will not change because we are assuming x equal to t and y is also equal to t. So we can easily achieve this result as now when we substituting everything in terms of t, both is going to be the same. So we'll be getting integral 0 to infinity e power minus t square dt whole square. Taking square root on both sides, we get square root of pi divided by root 4 is 2. This is my answer. So we have evaluated the problem using the result which we derived earlier. Hope you understand, students.
Thank you for watching. We hope you found this video helpful. Stay tuned for more and keep up the great work. Subscribe to our channel and see you in the next video. Bye bye.